Okay, so let's have a look at the Junior Certificate Higher Level Maths Paper 1 for 2019, questions 5 and 6. Okay, so in part A here we are given three sets. A is the set of multiples of 2, B is the set of multiples of 3, and C is the set of multiples of 4. Write down a number that is in the intersection of these three sets. Okay, so if we write out set A, for example, we would have 2, 4, 6, 8, 10, 12, 14, 16, and so on. If we were to write out set B, that would be 3, 6, 9, 12, 15, 18, 21. Set C would be 4, 8, 12, 16, 20, 24, and so on. Now we've got to find a number that's common to all three. Well, we have the number 12 here, here, and here in all three. So 12 would be in the intersection of the three sets. Okay, so that's part A done. Let's have a look at part B. Explain why C is a subset of A. Why is set C here a subset of A? Well, you can see that it is, at least in the numbers that we've drawn out here. So 4 is in A, 8 is in A, 12 is in A, 16 is in A, 20 and 24 and so on. They will always be also in A. So why is that? Well, you could say since 4 is a multiple, 4 is a multiple of 2. Since 4 is a multiple of 2, all multiples of 4 will also be multiples of 2. Will also be multiples of 2. You could also say all multiples of 4 are even, and therefore divisible by 2, so will be multiples. So will be multiples of 2 also. Okay, so that's it for part B really. Part C here, we have all three sets shown in our Venn diagram here. So these are multiples of A, these are multiples of B, and these are multiples of C here. Now because C is a subset of A, so all of these multiples of 4 here are going to be somewhere in this circle here, multiples of 2. So there will be nothing out here, because all the multiples of 4 have to be multiples of 2 as well, so they have to be within this circle. So in the Venn diagram we'll have no, so it says there are two regions in the Venn diagram that have no elements. So those two regions are going to be here and here. These two regions are multiples of 4, but remember all multiples of 4 are also multiples of 2, so any numbers that would normally be in here would be pushed into this region here. Write an X in each of these two regions in the Venn diagram above, so I've done that. Okay, each of the other 5 regions in the Venn diagram has some element. In each of these 5 regions in the Venn diagram above, write one of the elements in that region. Okay, so we've got to pick numbers that will go in 1, 2, 3, 4, 5 in one of these 5 regions, or in each of those 5 regions. So let's pick some numbers. Now, we want to find a multiple of 2 only, but not a multiple of 3 and 4. So that would be 2. 2 is a multiple of 2, but it's not a multiple of 3 or 4. What about a multiple of 2 and 3, but not a multiple of 4? Well, that would be 6. 6 is a multiple of 2. 6 is a multiple of 3, so it goes in the middle here, but it's not a multiple of 4, so it doesn't go in this circle here. Now what about a multiple of 3? Well, we could pick 9. 9 is a multiple of 3, it's not a multiple of 2, and it's not a multiple of 4, so it goes in here on its own. What number can we put in here? Well, we've already done that previously. We picked 12, I think it was. So 12 is a multiple of all three. What about here then? A multiple of 2 and a multiple of 4, but not a multiple of 3? Well, let's pick, there are loads of them, but let's pick 8. 8 is a multiple of 2, 8 is a multiple of 4, but it's not a multiple of 3. So these are just some examples. You can probably find other ones yourselves. Okay, that's this part, I think. Each of the other 5 regions in the Venn diagram has some elements. Yeah, write one of the elements in each region. We've just done that. Okay, so that's that question finished actually. Let's have a look at question 6. Question 6, Polly and Ella ran a 5-kilometer race. The simplified graph below shows the time that it took Ella to run d kilometers during the race. So we have distance along the bottom and we have time along the vertical axis here, the y-axis. Normally it's the other way around. Usually you would have distance up along here and time along the x-axis, so you need to be a little bit careful here. So let's have a look. The simplified graph below shows the time that it took Ella to run d kilometers. So she ran 5 kilometers here in 26 minutes. One of the points on the graph is marked A, so we have that here. It looks like there was a change in speed here. Distance is on the horizontal axis, so they tell you that. For example, it took Ella 26 minutes to run the whole 5 kilometers. Okay, so it's important to look at this graph carefully, just see what's on the x-axis, what's on the y-axis. Now, the table below shows the total time that it took Poppy and Ella to run each of the given distances in the race. Now, using the figures in the table, draw a graph on the diagram above to show the time it took Poppy to run d kilometers during the race, 0 to 5. Distance is 0 to 5. So you can see that here. So we've got to draw a graph using these numbers here for Poppy's race. So let's do that. We have 1, 5 and 2, 10. So I'm going to go up and down here a little bit. So let's see, we have 1, 5 and 2, 10. So a distance of 1. I can do that here actually. We'll do it in this color here. So 1 kilometer. So yes, 1 kilometer 5 minutes. So 1 kilometer 5 minutes would put, we need to put a point here. 2 kilometers 10 minutes, so we got 2 here and 10 here. We have, let me see, 3:17, so we need to go 3:17, so 3, and there's 15, 16, 17, that would be here. And then we have 4:24, so 4 and 24 is going to be here. And then we finally have 5 and 30. So we have 5 and 30 here. Now you're going to have to connect these up. We're going to have a point here as well. So let's see. I'm doing this freehand. Oops, let me just redo that again. So it's going to look something like that. A little bit, I should have gone through the point here. You guys can use a ruler or whatever, but you should get a graph something like this anyway. Right, let's move on. You guys obviously can do a much better graph than me there. Using Ella's graph, fill in the 3 missing values in the table below. So we have 3 missing values here. So we have a distance of 2. We've got to work out 2, 3 and 4. The time it took to do 2, 3 and 4 kilometers. So let's have a look. And this is for Ella's graph here. So 2 minutes, or 2 kilometers I should say, is actually at the point A, and if we go over here we see that it's actually 5, 6, 7, 8 8 minutes. So for 2 we should put in 8. So let me do that. 2 we're going to put in 8. For 3, we just move this down a little bit. For 3 we're going to put in, let's see, we have 3 here. So we're going to go up to the graph here and across here to 14. So 3 is going to be 14. And 4 is going to be here, so 4 will be, it's exactly on 20 there. 4 is going to be on 20 minutes. Okay, so that's using Ella's graph. Fill in the 3 missing values in the table below. So we've done that. That's that one done. Show the Poppy's times in the table do not make a quadratic sequence. So Poppy's times. So let's write those out. So we have, these are Poppy's times here. Total time taken for Poppy in minutes. So we have 5, we have 10, we have 17, we have 24, and we have 30. We've got to show that they do not make a quadratic sequence. So usually what we do here is just find the difference between each pairs of numbers here. So let's see, we have 5 up to 10, that's going to be plus 5. 10 up to 17 is plus 7. 17 to 24 is also plus 7. 24 to 30 is plus 6. Okay, so let's go again. Now if this was a quadratic sequence, these numbers here, these differences here, should be all the same. But we go from 5 up to 7, so that's plus 2. 7 to 7 is just plus 0 if you like. That's a plus there. And 7 to plus 6 is minus 1. So we can say Poppy's times do not make a quadratic sequence, since the second difference or the second change are not constant. They vary, in other words. Okay, second difference is not constant, therefore it's not a quadratic sequence. Okay, let's have a look at part D then. It took Ella 26 minutes to run 5 kilometers. Work out Ella's average speed for the race. Give your answer in kilometers per hour, corrected 2 decimal places. So we have 26 minutes to do 5 kilometers. So we want to work out the average speed. So speed is distance over time. Speed is equal to distance over time. So in this particular case, it's the distance of 5 kilometers divided by the time. Now we want kilometers per hour. So we want 26 minutes. We have 26 minutes. We want to convert that to hours because we want kilometers per hour, not kilometers per minute. So what you need to do here is change 26 minutes to hours. How many hours is 26 minutes? Well, it's 26 60ths. There are 60 minutes in an hour, so it's 26 over 60 hours, which is equal to 13 over 30 is the simplified fraction. So really the time is 13 over 30. So in this particular case, when you work that out, we've got to work this out corrected 2 decimal places. So in this case it's going to be 11.54. 11.54 kilometers per hour. Okay, so that would be her average speed. So this is Ella's average speed. Okay, corrected 2 decimal places. Now, tick the correct box to show what happened to Ella's speed after 2 kilometers, which is marked A on the graph. Tick one box only and justify your answer. Well, we have Ella's speed increased, Ella's speed decreased, or Ella's speed stayed the same. Now, if we go back to the graph here, this is Ella's graph here. Okay, you can see there has been a change in speed, but you've got to remember here that we have distance on the x-axis, time on the y-axis, so you've got to be a little bit careful here. So because remember, speed is distance over time, so it's what's on the x-axis divided by what's on the y-axis in this particular case. Now what I'm going to do here is just work out the slope of this line here and the slope of this line here and write down the units, and we'll just compare the two. So you can see it's a straight line from here to here. It's a straight line from A up to the end here. So what I'm going to do here is take, I'll just draw this in actually. I'm going to take the triangle, this triangle here, okay, this triangle along here. So what is that? Well, it's 2 on the x-axis, so it's 2 kilometers, and up along here we've got 5, 6, 7, 8. We've got 8 along here, so it's going to be 8 over 2. 8 over 2. So if I just go back down, and we'll do that first. So let's actually just up a little bit here. So I'm going to do it here. So the slope from 0 to A is 8 over 2, which is equal to 4. Now what are the units here? Remember, the 8 is the time in minutes, and the 2, that's the distance in kilometers. So it's 4 minutes per kilometer. 4 minutes per kilometer. It takes her 4 minutes to do 1 kilometer. And now the slope from A to the end. So we just go back up again. So from A to the end. So let's take the total distance from A to the end. Well, the distance here is 2 kilometers. The distance up to here is 5 kilometers. So she's gone 2, 3, 4, 5. She's gone 3 kilometers. She has gone 3 kilometers. I'll just write that down here just to remind me. She's gone 3 kilometers from A to the end. But what time has that taken? Well, it's from 8 up to 26. 8 up to 26, so that's 18 minutes. So in this particular case, it's going to be, again, I'm taking, if you want to look at it from a slope point of view, this is going to be from here. So I'm going to do rise over run here again. Whoops, that's gone out there. So I'm just going to do, this is going to be your 18 here, and this is going to be your 3 here. So it's going to be 18 over 3. So let's just go back down and do that here. So you've got 18 over 3, which is equal to 6. And again, this is minutes per kilometer. Minutes per kilometer. So from 0 up to A, she does 4 minutes for each kilometer. From A up to the end, it takes her 6 minutes to do each kilometer. So what actually happens there then? She must slow down. It takes her longer to do each kilometer. So it says justify your answer. Well, this is really it here. You can write in it takes longer per kilometer after A. takes longer per kilometer after A. Okay, something along those lines anyway. So she's actually going to slow down. So Ella's speed decreases. So that's the answer there anyway. Okay. Right, next part F. Kieran also ran the 5-kilometer race. He drew the graph below to show the time that it took him to run d kilometers during the race. The part of Kieran's graph marked C is a vertical line. So this part here is a vertical line. Again, you have time along here and you have distance along here along the x-axis. What does the part C tell us about Kieran's running at this stage of the race? Give as much detail as possible. Well, you can say that he, let me just write that out here. Kieran stops running at this stage. This is at how many kilometers? 2 kilometers at the 2 kilometer point. At the 2 kilometer. Now he stops for, let's see, 10. He stopped at 10 minutes and he started again at 15 minutes. So he stopped for 5 minutes. So he stops for 5 minutes. What does part C tell us about Kieran's running at this stage of the race? Well, he stopped running and he stopped for 5 minutes. There isn't much more you can say about that, I think. No, we'll move on to the next section anyway. Now, Brendan says Kieran's graph does not show the total time as a function of distance. Give a reason why Brendan is correct. So Brendan says that Kieran's graph does not show the time on the y-axis is a function of the distance x along the x-axis. So the reason for this, let me just move this up and I'll just write down something here. Okay, so time is not a function of distance in this case. So time is not a function of distance, since at 2 kilometers there are multiple outputs or times. So for a graph to represent a function, you can't have one input giving you more than one output. So in other words, we're putting 2 into our function here and we're getting 10 minutes, we're getting 11 minutes, 12 minutes, 13 minutes, up to 15 minutes. So we're getting number of different outputs for the one input, and that basically doesn't represent a function. I mean, in set diagram and Venn diagram form, if you have, say, your inputs and your outputs, so these are your inputs here and these are your outputs. So say you have a few inputs here and you have a few outputs here. If this input goes to this output, this input goes to this output, and this input here also goes to this output here, then this is not a function. You can't have one input giving you more than one output, and that's what's happening in this particular case. So time is not a function of distance because 2 is giving you multiple outputs here. Okay, and I think that's it for these two questions actually.